According to the National Electrical Code, specifically Section 314.16b, there is a limitation on the number of extension rings that can be used with a 4-inch square electrical box. The code stipulates that only one extension ring is permitted to be installed on a single 4-inch square box. This regulation is in place to ensure the mechanical integrity of the electrical box assembly and to prevent overfilling the box beyond its listed capacity. Overfilling can lead to overheating, insulation damage, and potential electrical hazards. When installing electrical wiring in devices, it is essential to adhere to the National Electrical Code regulations to maintain safety and compliance. This includes understanding the limitations on the use of extension rings. Always consult the most recent edition of the NEC and local amendments for the specific requirements in your jurisdiction. This helps guarantee electrical installations are safe, reliable, and meet the required standards. Firstly, understanding the definition of an extension ring is crucial. An extension ring is an accessory used with electrical boxes to increase the volume of the box. This is often needed when existing wiring is insufficient to accommodate additional devices or when modifications to the electrical system require more space within the box. Extension rings come in various sizes and shapes, but they are typically designed to mount directly onto the existing electrical box, providing additional depth and volume. Secondly, the purpose of limiting extension rings is to prevent unsafe conditions. Overfilling an electrical box can lead to several problems. One major concern is the potential for overheating. When too many conductors, devices, and connections are packed into a small space, the heat generated by the current flow cannot dissipate effectively. This can cause the insulation on the wires to degrade, leading to short circuits and fires. Thirdly, the National Electrical Code sets standards for box fill to ensure that electrical boxes are not overfilled. Box fill calculations take into account the number of conductors, devices such as switches and receptacles, and any internal clamps or supports. Each of these items contributes to the total fill volume of the box, and the total must not exceed the maximum volume specified for that box size. Fourthly, Section 314.16b specifically addresses the use of extension rings and limits the number to 1 on a 4-inch square box. This limitation is in place to maintain the mechanical integrity of the box assembly and to prevent excessive strain on the box and its mounting. Using more than one extension ring can weaken the assembly, making it more susceptible to damage or failure. Fifthly, the 4-inch square box is a common size used in electrical installations. Its dimensions provide a reasonable amount of space for making connections and housing devices. However, even with a 4-inch square box, it is still possible to exceed the maximum fill volume if too many conductors or devices are added. Therefore, it is essential to perform box fill calculations to ensure compliance with the NEC. Sixthly, when calculating box fill, each conductor entering the box is counted. Conductors that originate outside the box and terminate inside the box are counted as one conductor. Conductors that pass through the box without being spliced or terminated are also counted, with some exceptions for grounding conductors. Each device, such as a switch or receptacle, is counted as 2 conductors based on the volume allowance specified in the NEC. Seventhly, internal clamps or supports within the box also contribute to the box fill volume. These clamps are used to secure cables entering the box and prevent them from pulling on the connections. The volume allowance for clamps is typically marked on the clamp itself or can be found in the NEC tables. Eighthly, grounding conductors are treated differently in box fill calculations. The NEC allows a certain number of grounding conductors to be grouped together and counted as a single conductor depending on the size of the box and the number of circuits entering the box. This allowance is intended to simplify the box fill calculation process without compromising safety. Ninthly, when adding an extension ring to a 4-inch square box, it is important to recalculate the box fill to ensure that the added volume is sufficient to accommodate the existing and any new conductors or devices. The extension ring will increase the overall volume of the box, but it is still possible to exceed the maximum fill volume if too many items are added. Tenthly, if the box fill calculation indicates that the existing box is too small, there are several options available. One option is to replace the existing box with a larger box that has a greater volume capacity. Another option is to reduce the number of conductors or devices in the box, if possible. A third option is to use a different wiring method that requires fewer conductors. 11thly, it is important to remember that the NEC is a minimum standard, and local jurisdictions may have additional requirements or amendments to the code. Always check with the local electrical inspector to ensure that your installation complies with all applicable regulations. 12thly, proper box fill is crucial for ensuring the safety and reliability of electrical installations. Overfilled boxes can lead to overheating, insulation damage, and potential electrical hazards. By following the NEC guidelines and performing accurate box fill calculations, electricians and installers can prevent these problems and maintain a safe electrical system. 13thly, in addition to the box fill requirements, the NEC also specifies the minimum size of electrical boxes for different applications. These minimum size requirements are based on the number and size of conductors entering the box, as well as the type of devices being installed. Using a box that is too small can make it difficult to make connections and can increase the risk of damage to the conductors or devices. 14thly, the NEC also addresses the mounting and support of electrical boxes. Boxes must be securely mounted to a structural element of the building to prevent them from moving or shifting over time. The NEC specifies different methods for mounting boxes, depending on the type of construction and the weight of the box and its contents. 15thly, when installing electrical boxes in damp or wet locations, it is important to use boxes that are specifically listed for those locations. These boxes are designed to prevent water from entering and damaging the electrical components. The NEC also requires the use of watertight fittings and connectors to maintain the integrity of the enclosure. 16thly, the NEC also addresses the use of non-metallic boxes. Non-metallic boxes are commonly used in residential wiring because they are lightweight, easy to install, and resistant to corrosion. However, non-metallic boxes must be properly supported and protected from physical damage. The NEC specifies the types of wiring methods that are permitted to be used with non-metallic boxes. 17thly, when working with electrical boxes, it is important to follow safe work practices. Always disconnect the power before working on any electrical circuit. Use insulated tools to prevent accidental contact with live wires. Wear appropriate personal protective equipment such as safety glasses and gloves. 18thly, the NEC is a complex and ever-evolving document. It is essential for electricians and installers to stay up to date on the latest changes and revisions to the code. Continuing education courses and professional development programs can help ensure that electrical professionals have the knowledge and skills necessary to comply with the NEC. 19thly, the enforcement of the NEC is typically the responsibility of local electrical inspectors. Inspectors review electrical plans and inspect electrical installations to ensure that they comply with the code. They have the authority to issue citations and require corrections if violations are found. 20thly, the purpose of the NEC is to protect people and property from electrical hazards. By following the code and adhering to safe work practices, electrical professionals can help prevent electrical fires, shocks, and other injuries. The NEC is a critical tool for ensuring the safety and reliability of electrical systems. 21stly, in summary, when working with 4-inch square electrical boxes, remember that NEC section 314.16b limits the use of extension rings to 1 per box. This limitation is in place to maintain the mechanical integrity of the box assembly and to prevent overfilling the box beyond its listed capacity. Always perform box fill calculations to ensure compliance with the NEC and consult with local electrical inspectors to ensure that your installation meets all applicable regulations. 22ndly, understanding the principles of box fill calculations and the limitations on extension rings is crucial for safe and compliant electrical installations. The National Electrical Code provides detailed guidelines to prevent overfilling and maintain the integrity of electrical boxes. By adhering to these guidelines, electrical professionals can minimize the risk of electrical hazards and ensure the reliability of electrical systems. Remember to always consult the latest edition of the NEC and local amendments for the most current requirements. 23rd, when selecting an extension ring for a 4-inch square box, it is important to choose one that is listed for use with that specific box. The extension ring should be made of the same material as the box and should be properly installed to ensure a secure connection. Using an incompatible or improperly installed extension ring can compromise the integrity of the box assembly and create a potential safety hazard. 24th, in some cases it may be necessary to use a deeper electrical box instead of an extension ring. Deeper boxes provide more volume for conductors and devices without requiring the use of an extension ring. This can be a better option in situations where the box fill calculation indicates that the existing box is close to its maximum capacity. 25th, when adding new circuits to an existing electrical system, it is important to consider the capacity of the existing panel board. The panel board must have sufficient space and capacity to accommodate the new circuits. If the panel board is already full, it may be necessary to install a subpanel to provide additional capacity. 26th, when running new wiring, it is important to follow the NEC guidelines for wire sizing and overcurrent protection. The size of the wire must be appropriate for the ampacity of the circuit, and the overcurrent protection device circuit breaker or fuse must be sized to protect the wire from overload. Using undersized wire or an improperly sized overcurrent protection device can create a fire hazard. 27th, when making connections in electrical boxes, it is important to use approved connectors and splicing methods. Wire connectors must be properly sized for the conductors being joined, and they must be securely tightened to ensure a reliable connection. Improper connections can cause overheating, arcing, and potential fire hazards. 28th, when installing electrical devices, it is important to follow the manufacturer's instructions. Devices must be properly mounted and wired according to the instructions. Using the wrong wiring method or improperly installing the device can damage the device and create a safety hazard. 29th, when working with electrical systems, it is important to be aware of the potential hazards. Electrical shock can be fatal. Always disconnect the power before working on any electrical circuits and use insulated tools and equipment. 30th, regular maintenance and inspection of electrical systems are essential for ensuring safety and reliability. Electrical panels, wiring, and devices should be inspected periodically for signs of damage or wear. Any problems should be corrected promptly to prevent potential hazards. 31st, it's important to recognize that the NEC provides minimum safety standards. While adherence to the code is essential, it's often wise to exceed these minimums for enhanced safety and reliability. For example, using a slightly larger box than required by the box fill calculations can provide more working space and improve heat dissipation. 32nd, consider the long-term implications of your electrical work. Electrical systems are often expected to last for many years, so it's important to use high-quality materials and workmanship. Taking the time to do the job right the first time can save time and money in the long run. 33rd, remember that electrical work is not a do-it-yourself project for untrained individuals. Working with electricity can be dangerous, and it's important to have the knowledge and skills necessary to do the job safely. If you're not comfortable working with electricity, hire a qualified electrician. 34th, the proper selection and installation of electrical boxes and extension rings are crucial for ensuring the safety and reliability of electrical systems. By following the NEC guidelines and adhering to safe work practices, electrical professionals can prevent electrical hazards and maintain a safe electrical environment. 35th, always prioritize safety when working with electrical systems. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others from electrical hazards. If you're ever unsure about how to do something, ask a qualified electrician for help. 36th, continuous learning and professional development are essential for electrical professionals. The electrical industry is constantly evolving, and it's important to stay up to date on the latest technologies, codes, and best practices. Continuing education courses and professional certifications can help you enhance your skills and knowledge and advance your career. 37thly, remember that the electrical code is a living document that is updated regularly to reflect changes in technology and industry best practices. It's important to stay informed about the latest changes to the code and to understand how they affect your work. Subscribing to industry publications and attending training seminars can help you stay up to date on the latest developments. 38thly, the goal of electrical safety is to protect people and property from electrical hazards. By following the NEC guidelines and adhering to safe work practices, electrical professionals can help prevent electrical fires, shocks, and other injuries. Safety is everyone's responsibility, and it's important to make it a priority in all aspects of electrical work. 39thly, always double-check your work to ensure that everything is properly installed and connected. A simple mistake can have serious consequences, so it's important to take the time to verify that everything is done correctly. Having another qualified electrician review your work can also help identify any potential problems. 40thly, remember that electrical work is a regulated profession. In most jurisdictions, electricians are required to be licensed and insured. Hiring a licensed electrician ensures that the work will be done safely and in compliance with the electrical code. It also provides you with recourse if there are any problems with the work.